So hi, my name's Tim Bray. I work for Google. I have to talk to you today with the hat on because the lights are pretty bright up here, and if I take the hat off, I run the risk of causing eye damage with the gleam off my bald head. So I have a lot of stuff today, and I'm probably going to run through the whole 40 minutes. So if I say anything that seems like really wrong or needs further explanation, or you want to have an argument, I'm going to leave here and proceed directly down to the O'Reilly booth and have an office hours there. Starting right after the session. So please, if you'd like to talk about this stuff, and who doesn't like to talk about identity, come on down and let's talk about it. Okay, so identity. There's bad news and there's good news. So here's the bad news. If somebody comes to your site, to your app, and they just get signed in, no fuss, no muss, no trouble signing in, they don't sit there and say, wow, those guys have it together. That was a great sign-in experience. And then if they've been using it for a while, and they wake up in the morning and they don't read a story about how you leaked all their passwords all over the internet, they don't think, oh, I feel good because those guys are taking care of my passwords. On the other hand, if they come to your place and the logging in is painful and slow and irritating, well, you know what? They don't. They go somewhere else. And if they do wake up in the morning and discover that the password that they used on your site, which they also used at their investment banker and their dwarf porn site, they're going to feel really, really bad about that, and you will too. So that's kind of the downside of identity. It's one of these things where if you do a perfect job, nobody ever notices, and if you screw up, well, that's really bad. But I actually have a little bit of good news today. First of all, we and a lot of other people around the industry have been working really hard to make it easier for developers, people like you, to do the right thing. So with any luck, I bring you less work, and that's always a good gift. And there actually are, even better than that, there are a few actual goodies, user-perceptible good things that fall out of some of the modern, better new technologies. So let's suppose you're going to build an app. You're going to build a site. You're going to get up there on the web. So depending what framework you're going to use, you need to know who your users are. You need to get them logged in. You need to have a notion of identity. So you're going to go and Google, if you're using Django, you're going to go saying Django user management or Rails user management or something like that. And you're going to find out which package to use. I selected a few of the better known ones around here. And these things will, have a database of your users and manage them stuff. And most of them have pretty sensible APIs. And a few of them even have good user experiences. In particular, I noticed the Node.js ones seem to be doing a focus on user experience. So my job here today is to convince you not to do that. Don't use these things. Don't store user passwords. Actually, of the things on the screen there, OAuth seems somewhat less actively damaging than the others for reasons we'll get to. But so what happens when you pick one of these and deploy it? So let's go straight into demo mode here. How many of you have Tumblrs? Probably quite a few, eh? So here we are in Tumblr, and oh, hey, I'm going to make a new Tumblr. And it says, okay, there's an email, sure, and a username, and now provide a password, please. And the user's staring at this screen here, looking kind of blank, but in their heart, they're going, no, not another password! They really are. So when they're confronted with this situation, what do? One option is they pick a really easy password to remember, because, remembering passwords is hard, and we all have too many, which makes it, extra easy for the bad guys to crack their account. Alternately, they can have a good password and use that same good password forever, including on your dog grooming tips site, as well as their NASDAQ investment account, right? Thus, making life easier for the bad guys. Alternatively, they could just go away. Say, I just can't face the thought of making another account and a password. I'm not going to do it. I'm going back to Google and search somewhere else. Another thing they could do, and this sounds weird, but it's not a crazy idea, just type some random gibberish into the password field. Don't bother to try and remember it. It'll keep your session alive for a few days. And when you come back and you can't remember it, just go and reset your password via the email reset, and you'll be fine. Another approach, which some people do, is to use one of the password managers, like 1Password or KeyPass or LastPass. How many people in the room are using those? Yeah, I'm seeing a lot of hands go up. So I recommend those. They're fine. I personally have had like a huge amount of trouble getting civilians, non-geeks, to use those things, particularly on mobile devices. Oh yeah, well you just do the switch app thing to get to the password manager, and you type in the password manager master password, and you find the account you're trying to get into, and you copy the password, and then you switch back to the app you're trying to get into, and you paste the password in. It's so easy, right? You get some hostile stares when you do that. So I'm not really sure that scales to a solution to the problem. So what you're doing is imposing an uncomfortable choice, an unpleasant choice on users. And that's a bad thing. Whenever you can avoid doing a thing like that, you should. And it gets even worse than that. Talking about inflicting pain, probably you want the passwords your users to choose to be secure. So if you go and search Google for password rules, here's the top site. And here's a typical set of password rules. I wouldn't want to mention the name of the famous company whose rules these are, Intel. This is mean. This is really, really unkind. Don't do it. So if you insist on using one of those modules and having your own username password store, you are making people's lives painful, and you are globally decreasing the security of the internet. You are peeing in the swimming pool. Don't do that. A less secure internet is bad for your business, it's bad for Google's business, and more important, it's bad for people's lives. So we really need to start getting out of the password business, but maybe you got it. There's some reason of policy why you have to have your own accounts. So if you're going to do it, of course, you're going to do it the right way. You're going to store salted, hashed, encrypted passwords, right? With a modern encryption algorithm that hasn't been, rainbow tabled out of existence, right? And you're going to have an email flow for lost passwords, right? And you're going to have logic for people to change their password, right? And then you're going to have a flow for when people change their email address, because, hey, people change jobs and ISPs and things like that. And you're going to have a flow so they can do that. And you're going to have defensive logic to notice when some person's been logging in from the same IP address from a Mac in Toronto for the last 17 months and suddenly shows up from a Windows box in Vladivostok. And you're going to have two-factor authentication deployed to do that, right? And most important of all, you are going to found and fund and maintain a help desk so that when people have trouble logging into your site because something went weird in your login module, they can call up and get help. So I strongly recommend you not do any of these things, because it's a lot of work, it's painful, it's hard to get right, and you might end up being these guys. Now, I know that you guys here in the room are obviously all much smarter than the BBC and the IEEE and, the other people in here, and whereas they did something wrong when they deployed their user account storage, you're not going to do that. You're going to be smarter than that, and you're going to have a happy ending. Only maybe not. The bad guys are out there. I talk about the bad guys in a sort of an abstract way. I thought we should actually go visit them. So here's a website called byaccess.com. That's a real-life website. You can go there. It's in Russian, but Google Translate works pretty well on it. And this is where you can buy stolen accounts. And if you look at it, the leftmost column is the kind of account you can buy, mail.ru, and then there's a number for sale and things like that. And the price, which is usually like $5 per thousand. Let's brag a little bit. If you get to Gmail, you'll notice that the number of addresses for sale is smaller, and the price is $100 instead of $2 or $3. Facebook's also pretty good. The numbers are all over the map here. Usually the numbers of Facebook accounts and Google accounts for sale is very small, often 0. There really are monsters under the bed. And they're coming for your users, and they're coming for your users' passwords, and your users' passwords end up here, unless you do it all just right. So assume you'd like to get out of the password business. This is starting to become more and more of a mainstream choice. The idea is you go with somebody to be an identity provider, we say IDP, and, Facebook, Twitter, Google, whatever, Yahoo. You put a sign in with these other people button on your site. Then you become what's called a relying party in terms of signing in. We abbreviate that RP. RP also stands for good person, responsible citizen of the internet. And this works. People are more and more willing to do this. But we have what I think is a pretty obvious scaling problem here, because we call these pages NASCAR pages because they have too many stickers on them, just like a NASCAR racing car. And it's going to be really hard to fit more than 2 or 3, log in with buttons on a page and have it retain any sort of design integrity and be a good user experience. I don't know what the right number of identity providers on the internet is, but I'm pretty sure it's not 2 or 3 or a number like that. And I think there's room for a lot of experimentation in, what kind of organizations should be identity providers. And I think banks, universities, post offices, who knows? But we don't have room for all of them. So the conventional approach we're taking isn't all that scalable. Let me show you some alternatives that I think are going to work pretty well. Here is a website I made, a simple little demo website I made. It's called favcolor.net, and it does one thing. It remembers your favorite color. So let's go over there. And you saw a flash of its home screen, but the landing page redirected over to this thing, which is called Account Chooser. Now, this is also sort of a NASCAR, and it gives you a bunch of options to log in. But they're not just raw random IDPs. These are accounts that you have actually used to log into one site or another on the internet. And even though it says accountchooser.com in the address bar, it's all in HTML5 local storage. It's all secure. Nothing has ever crossed the internet. So if I want to use this thing, I see that I've logged in with tbray@textuality.com via Facebook. So I click on that, and boom, it goes in there. It knows my favorite color, which is a violent purple. Let's change it to something nice. Okay? And I'll log out. And then we'll go back, and I say, oh, that same address, I can log into that same address through Google. And we'll go through the Google IDP, and bang. See, it's changed my favorite color. So what you're seeing there is one-click sign-in. You would like your site to have one-click sign-in. It's a good thing to have. So let's log out. And you'll see that I also have here a Gmail address. So let's log in with that one. And, oh, wait a second. I haven't done this before. So Google says, hey, is it okay to be an IDP, for me to be an IDP for this guy? And you say, yeah, okay. And then it goes in, and it says, well, it doesn't know my favorite color, so it picked one at random. So instead of seeing one-click sign-in, what you saw there was two-click sign-up. Getting somebody you've never seen before with an account on your site in 2 clicks with no password. Not bad. Good user experience and very secure. Here's another approach I'd like to show off. This is a website called Poetica, which is a creation of Bray and Cook, whom I suspect some of the people in this room know. So let's just sign in here. And I'm going to start typing my email address. Whoa, look at that. It looked at the email address, and it figured out, oh, Google's the right IDP for that person. I've actually got a project going on that I'm working on right now to build a web service to do that. The input, you send it an email address, and it sends you back a little chunk of JSON saying, here, I think this is the best IDP. In this particular case, he did the trick of going and looking at the MX record for that domain and seeing that it was at Google and saying, oh, okay. But there's lots of other tricks, too, and there's things like WebFinger and WebFist and lots of other heuristics you can use. So that is what I think we would like the future to look like. So how are we going to get there? What technologies are we actually going to deploy to provide a user experience more like that and less like typing a painfully long password in on a mobile device? So we at Google are betting very heavily on OAuth 2 and OpenID. We are looking at a multi-protocol future. The identity protocol of the past was SAML, and it's not being deployed very widely on the internet, but it's not going away in the enterprise. Mozilla is also talking about something called Persona, which looks quite technically sound to me. I don't think any of these are going to drive the others out. Now, I'm going to talk specifically about OAuth for a few minutes, but the remarks apply generally to most modern identity protocols. So OAuth is kind of complicated. It's taken some large groups a long time to bash it out and get it right. And I don't want to spend this whole talk talking about how OAuth works. So I thought I would simplify things by making an oversimplified diagram of just a few essential parts of OAuth so that you can get a picture for how it works. Joking aside, if you actually want to find out how OAuth works, here's a couple of slides. And rather than you trying to copy those URLs down, let's go over to the browser again here. And I'll just tweet them. Okay. So this slide would suggest that you think of OAuth as a great big complicated machine, which is reasonably accurate. The good news is you really don't have to understand what goes on inside it to use it. The quality of the libraries and the packaging that's going on around allows you to basically just call an API that will, in most cases, do the right thing. So, whereas I said I don't want to do a technical deep dive on OAuth, I want to talk about a few of the technical artifacts. Because I think, well, first of all, I just think they're interesting and potentially useful and things that might enrich the level of things you can do. So consider OAuth as a great big complicated machine, and you push the go button, and it cranks, and some number of microseconds later, what comes out is this. And that's called an access token. It's just a string of characters, which, by the way, are designed so you can put them in a URL without breaking anything. And they are not designed to be particularly human readable, and there's not that much you can tell by looking at them. And here's how you use an access token. You just shoot it along with any old HTTP request using the HTTP authorization header. Many APIs also allow you to stick it in as a name equals value URL parameter. But don't do that. It's less secure. It might get logged. It invades the URI design space and so on. Use the HTTP header method. So that particular URI that we're fetching there is a person's Google Plus basic profile. And you'll notice that nowhere in the URL does it say who we're asking for, because that's implicit in the token. I've already said access tokens are opaque, and your app can't really use the payload, but that doesn't mean they're terribly secret. You can actually peek inside the access token. Let's do that. Turns out Google has a token info endpoint you can get at with good old curl, and it'll give you a look at what was inside the token. I'm not going to walk through this field by field, but it reveals who asked for the token and what they asked for and what app they were running. It also reveals one very important fact. Access tokens often don't live very long. This particular one had a lifetime of an hour, of which 56 minutes were left by the time I actually peeked inside it. So they're not really hard to understand. The important thing is that since they are not secrets or encrypted or anything like that, you absolutely must use HTTPS all the time, anytime you're shipping this kind of thing around. But you were anyhow, right? Use HTTPS for everything, and then you won't, accidentally not use it for the important thing. So these things are bearer tokens. So let me give you a notion of something that you can do that may feel a little weird and strange, but is actually perfectly legit. Suppose I have a mobile app that captures video and shoots it upstream and stores it in Google Drive. And I'd like, after I've stored it, to have a thumbnail and some summary about the running length and things like that. Well, I totally do not want to compute those things on a mobile device. A mobile device can only barely play video, let alone process it intelligently. So what I want is my own software on my own server to go up there and compute that for me. So I get an access token in my mobile app, and I just send it over the network to my back end, and it allows my back end to reach into Google Drive, read the video, process the video, make the thumbnail, and send it to me. Perfectly legal, perfectly legit. These are power tools. You can cut your legs off with them, so be careful. I eventually became convinced that the perfect analogy for a bearer token is a hotel room keycard. It works almost exactly the same. There's nothing written on the outside that says what it does. It grants unconditional access to some particular resource, namely, your room in the hotel. It is time limited. You might as well give it back when you check in because it's not going to work anymore. And to get it, you have to prove who you are, with some ID and things like that. So it works pretty well the same. And you can give it to somebody else to go get something out of your room for you. Okay. Now, one of the most important things about access tokens is that they expire. They don't last that long. And suppose you want to offer a service to somebody 24/7 by 365, even when they're not there. In that case, you press the next button on the big OAuth machine, and it spits out one of these, which is a refresh token. Once again, not terribly instructive to look at. It has a slightly more complex HTTP dance to use it. But the idea is, once you get authorized for something and you get a refresh token, you can every time your ordinary token runs out, you can swap it and get a new one. So once you've got one of these things, you can work, as I said, 24/7 by 365 on somebody's behalf. Obviously, these are never issued without the user being prompted saying, is that okay? But the thing to remember, if you're going to use these, the security requirements are even more stringent because these things are more powerful. And the expectation is once you get a refresh token, you're going to keep it forever in some sort of secure storage, not just, a JavaScript variable. Yeah, once again, got to do it over TLS. OK, so those are the regular tokens. Now, OAuth 2 is not actual an internet protocol in the way that HTTP or SMTP or something are, in that, Google protects its stuff with OAuth, and Microsoft protects its stuff with OAuth, but that doesn't mean you can have an abstract general OAuth client that will interoperate with these things. OAuth is actually a framework for building interoperable protocols. And one of the most interesting ones that's being built is this thing called OpenID Connect. We're going to have to push the questions back till office hours. To OpenID Connect. And OpenID Connect has a different flavor of OAuth token, of which this is an example, called an ID token. And as you can deduce with your awesome powers of observation, it's bigger. And if you look really, really close, it's got a couple of dots in it. And the dots divide it into 3 parts, like that. And it turns out that the 3 parts are the first part is not encrypted. It's just base64 JSON. So if you look inside it, it tells you what the signing algorithm is and what the ID of the key is, the thing that begins AD to A50. And then the middle part that we're not looking at here is the payload that's being signed. And the red stuff on the end is the actual signature. OK? So to actually check whether it's valid, you have to go get a key to check it with. So you can go and fetch Google's public key, since this was issued by Google. And that's a real URL. You can go and look at it and look at the certs. And there's our public certs. And then you can use those certs to check the signature and make sure that the ID token was valid. Now, when I say this, I'm not suggesting you actually write the code to do that. These things are well supported in nearly every major programming language these days. So that's how you would do it in Ruby, for example. You get one of these things, and you verify it. And then you know you can use it. Once you've done that, the middle, once you check the signature is valid, is once again just base64 JSON. So you can look inside it. And I'm not going to walk through these, but it's got a lot of useful information on who issued this thing, what individual user ID was signed in, which app asked for it, which app it was intended for, when it's going to expire, so on and so forth. So these things have many of the same characteristics as the other kinds of tokens we've talked about. But it's incredibly useful. Let me give you a scenario that could be happening, even though I don't think it actually is yet. You probably know about flightaware.com, which is this really nifty website. You can type a flight number in, and it'll go and give you a snapshot of, on average, how late that runs, how early it arrives, how late it arrives, how often it's canceled, and if it's in flight, where the plane is right now and when it's expected to land. OK. There's another really useful website that I use a lot called tripit.com, which is a personal travel organizer that's really one of the very, very best. And I have all my trips on there all the time. So wouldn't it be neat if the mobile app for FlightAware could automatically just show me the status of the next flight that I want to be on? Well, you could do that. So you get an ID token, one of these things. And the FlightAware app sends it upstream to the FlightAware website. The FlightAware website validates it, says, yep, that was really issued to Tim Bray, and yep, it was really meant for me. So I'll send it through a back channel over to Tripit, and Tripit will validate it and say, oh, yep, that really was issued to Tim Bray, and yep, it really was issued for FlightAware. And since we have a business partnership, I've agreed, I'll send them back the flight number of Tim's next flight, and boing, I see the flight status of my next flight. All sorts of neat tricks like that you can do. So that's the good part. The bad part is, as I said, these things are kind of complicated. And the fact of the matter is that even though the mechanics are kind of cool, and a lot of people who help build them care about them a lot, people like you don't. And for this to succeed, it is absolutely essential that we worry not just about the user experience and the security. It is absolutely essential that we also worry about the developer experience. And that's the good news. We are actually getting to the point where there are sane APIs on a wide variety of platforms you can call, and the right thing will happen. Let me show you a couple more demos. So this is sort of like the very high end. This is the Google Plus sign-in thing, which is over here. Yeah. So this is a website called Fancy, which frankly I loathe, but they're a good demo for this. So if you say sign in, you get a typical NASCAR page. Now, when you press I want to sign in with Google, you get, oh, a really fancy thing. Oh, this one not only wants to just log me in, it wants to make a social experience and share things I like with friends and stuff like that. And would I ever do this? No, I wouldn't. But let's say I wanted to, and I accept it. And not only, does it do that, it says, oh, hey, would you also like to install, Fancy on your Android tablet? No, I don't think I want to do that. And so all this comes, Yeah, and so on and so forth. Okay, so now I'm logged into Fancy. Lucky me. Okay? And that is fairly easy to achieve. That kind of socially enriched login is fairly easy to achieve. The Google Plus sign-in thing also comes with a quick start, which is the simplest possible Ruby program that will do this kind of thing. And since all we care about is the sign-in button, that's all it shows. And if you sign in with this thing, you get a much simpler sign-in approval dialog. And it goes and pulls my Google Plus account and even goes and gets the pictures of the people who are in my circles and so on like that. Okay? So the question is, how much code do you have to write to achieve something like that? And the answer is not very much. On the JavaScript side, you get a bunch of boilerplate JavaScript you have to copy in. And there's a couple more JavaScript libraries you have to link to in your headers. But it's really not rocket science. It mostly just works. So that's on the JavaScript side. So for that simple sample I just showed you, on the Ruby backend, here's the code that does that. And the authentication stuff is totally trivial. Now there's an important point I want to make here. I could have done that OAuth authentication rather than by just calling the Ruby library here, by actually doing the JSON HTTP flows back and forth myself. And for some people that's more appropriate, and it's actually not that complicated. Similarly, when they go through there in the loop in the second half of the slide to pull out the pictures of the people, once again, you could do that perfectly easily by just shooting a single HTTP request at the Google Plus backend and give you a JSON with. Now, it comes paginated, so you have to thrash through the pages, and there's a little bit of extra work there. But it's not rocket science, and I suspect that the average attendee at this conference would have little trouble with doing that. I think that it's perfectly reasonable to use the libraries for everything, like they're doing on this slide. I think it's also perfectly reasonable to just get down there and do the raw JSON in HTTP, and combinations. You might want to use the library at the top there to get signed in, but then use the raw JSON to get at it. This stuff is pretty tractable for programmers. And I would think that there have been generations and generations of authentication and authorization technologies, the XACML and the SAML and the OpenID 1 and the OpenID 2 and OAuth 1 and so on. I think we can claim that the level of effort required with the current generation for developers is substantially less, qualitatively less. The availability of libraries is starting to be really quite acceptably good. And the security is not terrible at all. It's good enough for Google security people who are a pretty sharp-toothed bunch. Just because I'm showing Ruby doesn't mean Google is that big a Ruby fan. There's also Python and .NET and PHP and same. This isn't just a Google thing either. If you go and look at your Facebook or anybody else, they'll typically provide libraries in all the popular languages to do this kind of thing. Okay, so I'm running a little short on time, so I want to talk about one specific effort that I think is important for the user experience and for the developer experience, and that's what we're calling cross-client identity. This thing is, here's the notion. If you as a developer set out to create an app, these days, that probably means you're doing a website and an iOS app and an Android app. Those three legs seem to be sort of the bare minimum you need to get through the door to have something perceived as a plausible app. And that creates a problem in that from your point of view, the developer, you're creating a piece of software. And from the point of view of the people who are using it, they're seeing it as one piece of software. And it should be really, really unacceptable if they then have to authenticate themselves 3 times, or once to their mobile app and then once again to your website. So how do you avoid that happening? And this is what you call the problem of cross-client identity. And it's really important. I think it should have been implicit in what I've been saying so far, that every time you reduce the amount of intrusion and extra work you ask people to do to achieve a secure result, you end up increasing the net security because they're prepared to take it more seriously on the rare and increasingly rare occasions when you do have to get in their face and say, yeah, prove that's really you. So it's an unambiguously good thing to cut down the number of unnecessary intrusions on the user's workflow to accomplish authentication and identity tasks. So I love this cross-client identity stuff. It makes me so happy. I wanted to put on unicorns and rainbows. Unfortunately, Google Legal won't let me put anything on the slides unless it's paid for or publicly cleared. So I went searching for Creative Commons licensed unicorns and rainbows. That was the best one I could find. So the way we have managed to accomplish this at Google, and I suspect other people are doing much the same thing, is so for any of this OAuth stuff to work, your app has to be registered. So if you're going to run an app and do this OAuth stuff with tokens and so on, you have to go to developer.google.com, or it's code.google.com, I forget the URL, and register your app. And it'll give you a bunch of arcane OAuth stuff that you have to paste into various places in your API. And the reason of the unit of registration is called the project, and then there's separate things inside for your different mobile apps and your website and so on. In OAuth jargon, these things are called client IDs, but they're just different pieces of your app. And the thing that we were able to hang the hook on is that to create a project and put things into it, you have to be using your developer account. And we decided that was strong enough evidence that these are really from the same person, and the consequence of that is that if a user is authorized against one of them, they should be authorized against all of them. And that calls for some more unicorns and rainbows and sparkles, too. Now, this turns out to be a little bit of extra work. There's a web page here that explains how to do it, and there's some extra work you have to do to make this happen. But it's not really rocket science, and to the extent that you can avoid getting in people's face to ask for stuff, that's a win. So this sort of works at 3 levels. First is sort of automatic. If I've got an access token to give me access to, I don't know, my calendar or something like that from my website, well, if I ask for it again from a mobile app, I should just get it without the user being pestered. Is it okay to give this app access? Or anything like that. And that gets 1 unicorn and rainbow. The next one is being signed in. Once you're signed in to your mobile device, can you communicate that signed in status to your back end? I'll actually talk about that one a little more. And the coolest of all is, can you arrange so that on a mobile device or just a transient web browser, you can actually get a refresh token and store that in the back end so that you can launch something from a mobile device that works for the user 24/7 by 365, and we can do those things now. Just to make this concrete, let me give you a little example. So here's your typical mobile app. And every mobile app in the world these days has some sort of a server-side backend. Even the most moronic imaginable game is going to want to persist and share high scores or something like that. But I just can't imagine an app these days without a backend. And typically, you and your backend are going to talk to each other in a RESTful kind of way using HTTPS. And the reasonable question that needs to be answered is, who am I talking to? Anybody can connect to an HTTP server. And when you get a message saying, oh, Tim's new high score is 120, how do I know that that's really Tim? And also, I'd like to be kind of confident that it's my that app that's calling in. So it turns out that ID token trick I talked about earlier provides a very neat solution to the problem. You get an ID token on the mobile device. There's a nice API for that. You ship it off to the back end. The back end, and through HTTPS, of course, the back end can validate it. Once it's validated it, it knows who it's come from, and without having to pester me for further authentication, it can safely persist that high score for me. Something I should have said when I was showing you that ID token validation stuff is that it's cheap. You don't actually have to go off to Google and get the keys all the time, because we only roll the keys over every 24 hours or something like that. So all the smart libraries cache those keys, and so when you validate a token, that's a local object, no network traffic. It's efficient. Feel free to do it. So that's just one example of shared cross-client authentication. It's hot stuff. You should be doing it. It's a little bit of extra work. It's worth doing. At Google, in the identity group, we have really a lot of different APIs and different styles of doing things. Partly this is because OAuth 2 is big and complex enough that it lets us do it. And I discovered earlier this year that there was a lack of tutorial information. For every one of these APIs, there was lots of sample code and Java docs or equivalent explaining how to do it. What there wasn't was a path through saying, here's how you might, I want to do X. How do I do that? And so the Cookbook tries to walk you through that. I don't really have time to walk through the Cookbook in detail, but I would like to sort of summarize the state of play. Basically, these days, if you are doing and I'm talking about on behalf of Google, but I think the state of the art is fairly clean and competitive across the vendor landscape. If you are building a web app And by that I mean whether you're doing a traditional, with a strong server component web app or a modern single-page JavaScript app, either way, authentication is the state of the art is pretty good. The APIs out there for getting into OAuth and doing OAuth are pretty good, fairly painless. Pretty well any online player you go to will just say, download this JavaScript, go register your app, put this value in here, and it'll work. Okay? So that's the good news. On Android apps, the story is pretty good too. The greatest single weakness of OAuth is that it kind of assumes there's a browser there. And if you're in a native compiled app, whether that be on a desktop or a mobile device, you don't really have a browser. You can use the embedded browser or branch out to a browser, but those are not as satisfying results. So on Android, we were able to cheat and put the OAuth stuff right in the operating system, so you can just call an API and get a token and go ahead and do what you want with really quite reasonable safety. The people who have the toughest row to hoe are the people who are writing native apps, whether that be PC, Mac, Linux, or especially iOS. Even on iOS on Google, we really have to pull our socks up. If you have 3 different Google apps on your iPhone, you might end up having to type your Google password in 3 times. We're reducing that and working on it, but it is a bit of a lagging state at the moment. Okay, I'm pretty well done. I wanted to say 2 things. So I was somewhat surprised to discover when I got here that in OSCON, the OS apparently stands for OpenStack, because every bloody booth down there in the trade show is talking about OpenStack. So I am not an OpenStack expert, so I spent some time researching OpenStack's authentication story, which operates at 2 levels, one of which being the sort of the authentication APIs for administrative people, which aren't that great. I mean, they have usernames and passwords all over them. They do allow you to get tokens in a way that doesn't look terribly OAuth compliant, so your libraries aren't going to be terribly helpful. But, it's not entirely insane. At least they've thought about it. I was quite concerned, though, that, this somewhat solves the problem for the dozens or hundreds of administrative people who are using OpenStack to deploy apps and run them and so on. There seems to be nothing at all said for the many millions of user accounts of the users, end users of the apps that are being deployed via OpenStack. And I think, it would be a real value add if somebody in that community started thinking about, encouraging people not to be in the password business and to get into federated identity, and maybe start thinking about providing some tools and APIs along that direction. Not that I'm an expert. Maybe I just missed it. Okay, I'm pretty well done. I do want to leave you with a couple of messages. So the first message is, please be kind to your users. Do not make your users type passwords. In particular, do not make your users type passwords on mobile devices. In particular, do not make your users try to type cryptographically strong passwords on mobile devices, because nobody can. So don't do that. Second, be kind to yourself. Use the libraries. Whatever you do, do not try and write your own crypto. Bad things will happen. If you can get away with using the library rather than doing the JSON, do it yourself. This code from people like us and Facebook and Microsoft and Twitter and so on is fairly fully debugged and rather thoroughly thought through and gone over by security gorgons. And to the extent that you can use libraries written by other people, not only will you be saving yourself work, but you may be saving yourself, much worse pain. And third, just get out of the password business. You are decreasing the quality of the internet, you're decreasing the quality of the user experience, and you're screwing up everybody's business if you insist on thinking that you, for some reason, are special and have to force people to have their own password, even though everybody else is too. Don't be part of the problem, be part of the solution. Okay, guys, I'm out of time. Goodbye. Anybody who wants to argue with me about this stuff, come on downstairs, and if we argue long enough, they'll bring us beer, I bet. Okay? Thank you.